at one checkpoint. Fee growth inside any range at any time in one subtraction. No loops, no histories, because every formula here only ever consumes differences between inside values taken at 2 moments above can legitimately go below 0. A tick initialized late sitting next to one initialized early is enough. Okay, here's a question that sounds impossible. A liquidity position earns fees only while the price is inside its range. Price moves in and out thousands of times over months. Now tell me how many fees that position earned, without looping over any history and without storing anything per position except one checkpoint. Fee growth inside any range, at any time, in one subtraction. No loops, no history. That's the fee growth outside trick, and it's the single most confusing thing in Uniswap V3. It's also, once it clicks, the most elegant. This is section 4 of Building Uniswap V3 on the Zealynx Academy. Before the fees, though, the simpler half. Every initialized tick stores 2 liquidity numbers, and people mix them up constantly. Liquidity gross is how many positions reference this tick at all. It only goes up when you add and down when you remove. And its job is to answer one question: can this tick be deleted yet? When gross hits 0, nobody cares about this tick anymore, and it gets cleared. Liquidity net is signed. It's the change applied when the price crosses this tick. Added at a position's lower tick, subtracted at its upper. So the same position touches both ticks, but in opposite directions. Cross into the range, liquidity goes up. Cross out, it comes back down. That's the whole mechanism for tracking active liquidity as price moves. Right? Now the fees. The pool keeps one global accumulator per token. All-time fees per unit of liquidity. Simple, cheap, one number. But that global number counts fees earned across every price. Your position only earned the ones accrued while price was inside your range. So how do you subtract out everything else? Without walking through history. Here's the trick. Every initialized tick stores a value called fee growth outside. It's the fee growth accumulated on the side of the tick away from the current price, and that value has a beautiful maintenance property. When the price crosses the tick, away from the price flips to the other side, and the stored value stays correct if you just assign outside equals global minus outside. That's it. That's the entire cross function. One subtraction per crossing. No history, no loops. And once you have correct outside values on both boundary ticks, fee growth inside the range is just what's left after you remove everything below and everything above. Below, above, and then inside equals global minus below minus above. The two conditionals just read from the correct side. If price is at or above the lower tick, that tick's outside value is the below side growth. If price is under it, the outside value is describing the other side. So the below side growth is the complement. Let's walk it with real numbers, because this is where it clicks or it doesn't. Position range minus 100 to 200. Current tick 50, so we're in range. Global fee growth is 100. Drop the fixed point scaling, just think fee units per unit of liquidity. Tick minus 100 was initialized when global was 20, and price has been above it ever since, so its outside is 20. Tick 200 has outside of 10, from an old excursion above it that flipped back on the way down. So below is 20, read directly, because 50 is at or above minus 100. Above is 10, read directly, because 50 is under 200, and inside is 100, minus 20 minus 10. 70. Now 20 more fee units accrue with price still in range. Global becomes 120. The outside values don't move at all because nothing was crossed, so inside is now 120 minus 20 minus 10. 90. Your position checkpointed at 70. 90 minus 70 is 20. Exactly the fees that accrued while you were in range. It just works. And now let the price rise. Through tick 200. Crossfires and set that ticks outside to 120 minus 10, which is 110. Now the current tick is above 200, so the conditional takes the other branch. Above becomes global minus outside, 120 minus 110, 10. The same 10, read from the flip side. The books stay balanced straight through the crossing. This is the kind of thing that's much easier with someone walking you through it, which is most of what we do inside Zealynx Insiders, live sessions every week, reading real protocol code together, and office hours where you bring your own. Links below. Now, there's a part of this that bothers people the first time, and they're right to be bothered. When a tick is initialized for the very first time, what should its outside value be? Nobody was tracking it before now. There's no true answer. So V3 just decides. If the tick is at or below the current price, all historical growth is deemed to have happened below it, so outside equals global. If it's above the current price, outside is 0. And notice the code has no else branch, because 0 is the struct default. That is a convention, not a fact. It's a made-up number, and it works because every formula here only ever consumes differences between inside values taken at 2 moments. A constant offset cancels. The absolute number is meaningless. Only the difference is real. Which brings us to the part where a careless port destroys the protocol. Because those outside values are relative fictions, global minus below minus above can legitimately go below 0. A tick initialized late, sitting next to one initialized early is enough to do it. In Solidity 0.7 that wrapped silently and correctly. In 0.8 it panics, so you must write unchecked or the pool reverts on perfectly valid state. Skip that one keyword in the port and the pool breaks under completely normal use. And the wrap is harmless for exactly the same reason the offset is. The next subtraction, current inside minus your checkpointed inside, wraps back. The difference is exact in modular arithmetic. This is the canonical example of underflow being intentional and safe. Okay, let's write the 2 functions that matter. First, the payoff line. Everything not below and not above is inside. Global minus below minus above for both tokens, and the whole thing inside an unchecked block for the reason we just went through. Look at how small that is. 2 subtractions per token. That is the answer to how many fees did this position earn, for any range, at any time. Computed in constant time. No loop over crossings. No per position history. 2 subtractions. And now cross, which is the function that keeps all of it true. Every one of these accumulators gets the same treatment. Fee growth outside for both tokens, flipped. And then, the 3 oracle fields, the tick cumulative, the seconds per liquidity, and the seconds outside, flipped exactly the same way. You're writing those now and you'll fully understand them in section 13. But notice they follow the identical pattern. That's not a coincidence. It's the same idea applied to a different accumulator, all of it unchecked, including the timestamp math, where a uint32 subtraction wrapping is by design, and then it returns liquidity net, which is what the swap loop will apply to active liquidity as it steps across the boundary. The rest is the surrounding bookkeeping. Loading the boundary ticks, the 2 conditionals we walked through, the gross update with its cap check, the initialization convention, the sign flip between lower and upper, and clear. Let's run it. 17 out of 17. So, you now have the piece of V3 that most people never quite get. 2 liquidity numbers per tick, 1 for lifetime and 1 for crossings. And an accumulator that stores the wrong side on purpose, flips on every crossing, and turns an impossible-looking history question into 1 subtraction. Next episode is TickBitmap, which answers a different question. Given where the price is now, which is the next initialized tick? Because the swap loop can't afford to check them one at a time. And the answer is a single word of storage and some bit twiddling. See you there.